Welcome back, everybody, to another deep dive, this time into the world of, well, scientific thinking.
Yeah.
It's amazing how
It's a good one.
even like seemingly really simple questions can lead to some pretty mind-bending journeys.
Right.
And that's kind of what happened to these two students, Kesser and Steen.
Yeah.
They're working on this Nature and Innovation project for school,
Mm-hmm.
and it's all about like the scientific mindset.
Right.
And they kind of hit a wall.
They did. They hit a wall, and their professor, Mr. Hendricks,
Okay.
saw that they were really getting bogged down in all the details of research methodology.
Okay.
And he saw it as a chance to teach them something really valuable.
Yeah.
How to approach a research question
Uh-huh.
with the clarity and the rigor of a scientist.
It's like he gave them a superpower.
Totally.
Right, like to be able to cut through all the noise and like get to the heart of the problem.
Yeah, totally. And he uses a really clever example to illustrate his points.
Okay.
A project involving lizard signs.
Lizard signs.
Lizard signs.
Okay, yeah.
So you see, Kesser and Steen were struggling with the very question,
Uh,
how to design a study, how to
Yeah.
collect data that's actually meaningful,
okay.
and how to avoid bias.
Right.
Mr. Hendricks used this lizard sign idea as a framework for them to explore the scientific method.
I'm intrigued.
Right.
So tell me, what's the first principle that Mr. Hendricks emphasized? Where do we even begin when we want to understand something like scientifically?
It always starts with observation.
Okay.
Noticing something interesting in the world around you.
Right.
So for Kesser and Steen, that might be the lack of easily accessible information about
Gotcha.
the local lizard population.
But observation alone isn't enough. Right.
Right, you have to go deeper.
You have to go deeper, try to explain what you're seeing.
Exactly. You need to come up with an explanation.
Okay.
And that's called hypothesis formation.
Right.
Coming up with a testable explanation for your observation. So, for example, Kesser and Steen might hypothesize that placing informative signs
Yeah.
about lizards in strategic locations
Yeah.
could lead to more frequent sightings.
Okay. I'm seeing how the lizard signs tie into this now.
Right.
Beautifully.
Yeah.
But a hypothesis is just an educated guess.
It is an educated guess.
You need to put it to the test.
That's where experimentation comes in.
Yeah.
So Kesser and Steen would have to design a study
Right.
to see if their hypothesis holds water.
Uh-huh.
So, for instance, they could compare the number of lizard sightings in areas with signs
Right.
versus areas without signs.
And wouldn't they need to consider different types of data?
Yes,
Like
definitely.
not just how many lizards they see, but maybe what those lizards are doing.
That's a great point. You're spot on.
Yeah.
So Mr. Hendricks likely explained the difference between
Okay.
quantitative
Okay.
and qualitative data.
Yeah.
So quantitative data is all about numbers
Right.
and measurements. So like the number of lizards they see.
Makes sense.
Qualitative data is more descriptive,
Good.
like observations about the lizard's behavior,
Mm-hmm.
the characteristics of their habitat,
Right.
or even how people react to the signs.
I can see how both of those would be really valuable for a project like this.
Yeah.
It's like having all the different pieces of a puzzle.
It is like a puzzle.
Right. And each one kind of contributes to the bigger picture.
Exactly. And just like with a puzzle,
Yeah.
you need to look for patterns.
Right.
And you need to make connections
Yeah.
and analyze the data you collected.
Right.
And that leads to conclusions.
Okay.
Now, these conclusions might support your initial hypothesis,
Oh.
or they might lead you to revise it, or even come up with entirely new questions.
And isn't there a key concept that kind of underlies this whole process?
Yes.
Something that helps to ensure that the findings are reliable
Yeah.
and trustworthy.
You're talking about reproducibility.
Reproducibility.
Yeah. Mr. Hendricks definitely emphasized
Mhm.
that for a scientific finding to be considered valid,
Uh-huh.
other researchers should be able to repeat the experiment
Right.
and get similar results.
So it's all about establishing confidence in the research.
Yeah.
But I imagine it's not always easy to achieve that,
It's not.
especially when you're dealing with living systems, right?
Especially with living systems, yeah.
It can't. Yeah.
Biological systems
Yeah.
are very complex
Right.
and messy.
Yeah.
Right. Lizards,
Yeah.
unlike chemicals in a lab,
Yeah.
they have a mind of their own.
Right. They're not going to just sit still
They're not going to sit still.
and do what you tell them.
Right. Their behavior can be influenced by all sorts of things.
Oh, yeah.
For sure. Weather,
Right.
the availability of food,
Yeah.
even the presence of an observer,
Absolutely.
a curious observer.
So how do biologists even begin to account for all of that variability?
Well, one strategy is to use large data sets, which can help to smooth out those individual quirks
Okay.
and reveal broader patterns.
So the more data, the better.
The more data, the better.
Okay.
Statistical analysis is also crucial for identifying meaningful trends and determining the likelihood that the results you're seeing are due to chance.
Right.
Or to the factor that you're actually studying.
So it sounds like Kesser and Steen have a lot to consider.
They do.
As they design this lizard sign project.
They do.
But I'm curious, what are the potential benefits of using signs in the first place?
Yeah, that's a great question.
Couldn't they just observe the lizards without any intervention?
That's a great question.
Yeah.
And it really highlights the importance of thinking critically about your choices in research design.
Yeah.
So using signs could have some benefits.
Okay.
Like it could increase public awareness about the lizards.
Yeah.
Encourage people to pay more attention to what's around them.
To their surroundings.
To their surroundings, exactly.
Yeah.
They might even collect more data
Yeah.
if people are actively looking for lizards.
Okay, yeah, that makes sense.
Yeah.
But couldn't the signs themselves
Yes.
introduce bias?
Yes.
Or influence the lizard behavior in
Right.
a way that they didn't expect?
Absolutely.
Yeah.
And that's where the critical thinking comes in.
Right.
Kesser and Steen would need to weigh those potential benefits against the potential drawbacks.
Okay.
Right.
Yeah.
Could the signs attract more predators to the area?
Right.
Could they lead to habitat disturbance?
Yeah.
If too many people are drawn to the lizard hotspots?
Right.
These are all important considerations.
It sounds like Mr. Hendricks is teaching them not only about the scientific method,
Right.
but also about the ethical responsibilities
Yes, definitely.
of researchers.
That's a big one.
Right.
Huge.
Like you have a responsibility
You do.
when you're doing research.
Absolutely.
Yeah.
Scientific inquiry isn't just about gathering data. It's about understanding the implications of that data
Right.
and making responsible choices
Okay.
that benefit both our understanding of the world and the world itself.
This is where I think the deep dive gets even more
It
fascinating.
does. So let's explore some of those challenges
Yeah.
that Kesser and Steen are going to face
Let's do it.
as they delve deeper into this world of lizard research.
Okay.
You ready?
I'm ready.
Okay, so let's dive into those challenges.
Okay.
One of the first hurdles Kesser and Steen are going to face is figuring out
Yeah.
how to design their study in a way that minimizes bias
Right.
and maximizes the reliability of their data.
So how do they go about doing that? What are some of the key considerations?
Yeah, well, first off, they need to be very clear
Okay.
about their research question.
Okay.
What exactly are they trying to find out?
Uh-huh.
Are they interested in just the overall abundance of lizards?
Okay.
Or are they looking at specific behaviors like basking
Okay.
or foraging?
Right.
Or are they trying to assess the effectiveness of the signs themselves?
Right, because each of those questions
Exactly.
would require a slightly different approach.
Absolutely.
And that.
And once they've got their research question nailed down,
Oh,
they need to think about how to collect the data
right.
that will help them answer it.
Okay.
Direct observation is a very common method
Yeah.
in ecological research,
Yeah.
but it comes with its own challenges.
Like what? Isn't just watching lizards pretty straightforward?
It sounds simple, but there's a lot to consider.
Okay.
Where and when will they observe the lizards?
Right.
How long will each observation period be?
Right.
How will they make sure that they're not accidentally counting the same lizard
Oh, yeah.
multiple times?
Good point.
And how will they account for all those factors
Right.
that might be influencing the lizard's behavior?
Yeah, like the weather.
Like the weather.
Right, or predators.
Or predators, exactly.
It's like trying to hit a moving target.
Yeah.
Lizards aren't exactly known for, staying put.
Not at all. And that's why it's so important to have a well-defined protocol,
Okay.
a set of standard procedures
Yeah.
that ensure consistency and minimize bias.
Okay.
So Kesser and Steen would need to decide things like
Yeah.
how they will define a sighting,
All right.
how they're going to record their observations,
Right.
how they'll deal with situations where a lizard disappears from view
Right.
or behaves in an unexpected way.
And it sounds like they need to carefully consider the placement.
Yes.
Very
Takes up
important.
science, too.
Very astute.
Wouldn't just putting them up randomly
Yeah.
introduce bias into the study?
They'd want to avoid putting signs in areas that already have a high concentration of lizards, for
Right.
example. And they also need to think about
Yeah.
factors like visibility,
Mm-hmm.
accessibility,
Right.
and even aesthetics.
Oh, right. Like how it looks.
A sign that's hidden behind a bush
Right.
or looks unappealing
Yeah.
might not be very effective. Okay, so they've designed their study, they've collected their data,
Okay.
and now they have this mountain of observations.
Right.
What happens next?
Now comes the fun part,
Yeah.
data analysis.
Okay.
So Kesser and Steen would need to organize their data,
Mhm.
look for patterns, look for trends,
Okay.
and use those statistical methods to determine if there's a significant difference in lizard sightings between areas with and without signs.
So if they see more lizards in areas with signs, does that automatically mean the signs are causing the increase?
Not necessarily. There could be other factors at play.
Okay.
Maybe the areas with signs just happen to have more suitable habitat or more food sources. That's why it's so important to have a control group, a set of observations from areas without signs that serves as a baseline for comparison.
So it's like a scientific checks and balances.
Exactly.
Right, making sure that you're not jumping to conclusions.
You bet.
Too quickly.
And even if they do find a significant difference, they need to be cautious about making those causal claims. Correlation doesn't equal causation, as the saying goes. There could be other variables they haven't accounted for that are influencing the results.
It's a reminder that science is a process of constant refinement.
Absolutely.
You're always looking for new evidence. You're always questioning assumptions.
Always questioning.
And revising your understanding.
And that's one of the most exciting things about it. There's always more to learn, more to discover, more to question.
And isn't there an element of creativity in science as well?
Oh, absolutely.
I mean, coming up with those research questions.
Oh, yeah.
Designing that study.
Yes.
Interpreting the data.
For sure.
It all requires a certain amount of imagination and ingenuity.
Science is often portrayed as this rigid, formulaic process. But in reality, it's full of creativity and innovation. Kesser and Steen might come up with entirely new ways of observing the lizards, of collecting the data, of even designing those signs. The possibilities are endless.
This is all sounding so fascinating.
It is.
But let's bring it back to the lizard signs. For a moment.
Back to the signs.
What are some specific examples of the kinds of information they might want to include on those signs?
That would depend on their research goals. Of course. But let's say, for example, their aim is to raise awareness about the lizards and to promote conservation. They might include information about the different species of lizards in the area, their habitat preferences, or their role in the ecosystem.
And I imagine they'd also want to emphasize
for sure.
the importance of respecting the lizards and their environment.
Absolutely. They could include tips for observing lizards without disturbing them. Like keeping a safe distance, avoiding loud noises. They could also encourage people to report their sightings. Maybe through a citizen science program or a dedicated website.
It's like turning those signs into like mini ambassadors.
Exactly.
For the lizard population.
And who knows, those signs might even spark a lifelong interest in nature. And conservation in some young minds.
Speaking of young minds, I'm curious about the role of creativity. In the design of those signs. Like, I imagine they could be more than just informative. They could be visually appealing.
Absolutely.
They could be engaging.
Especially if they're targeting kids.
Right.
Our sources actually delve into some creative suggestions.
Oh, cool.
For lizard signs that kids could help design and paint.
I love that.
It's a brilliant way to make the learning process more engaging. And empower young people to become advocates for conservation.
Let's dive into those design ideas.
Okay, let's do it.
I'm all ears. What did they come up with?
Well, one suggestion was a classic lizards in the dunes sign. With, a vibrant image of a lizard. Against that sandy backdrop. And kids could go wild with colors and patterns. Really bringing those scales and bright eyes to life.
I can see it. Like simple but effective. Catches the eye of a hiker walking by.
What other ideas did they have?
What else?
Oh, they also imagined a lizard family scene. So think mama lizard, papa lizard, and a bunch of little baby lizards. All soaking up the sun or darting around the dunes.
Oh, that's adorable.
And kids could have a blast drawing, lizards of all shapes and sizes, capturing that diversity of a family unit.
I love it. Did they have any ideas that kind of like leaned into the mystery of lizards a little bit?
They came up with Lizard Hideaway.
Okay.
So a sign depicting a hidden burrow nestled in the dunes.
Right.
With just like a hint of a lizard tail disappearing inside.
Oh, that's cool.
And kids could get creative with textures.
Yeah.
Adding footprints leading to the burrow.
I love that.
Yeah, sparking curiosity and encouraging close observation.
So good.
Yeah.
Any others that kind of play with that sense of exploration?
The last one is all about lizard tracks.
Okay.
A close-up of those distinct footprints imprinted in the sand.
Yeah.
So kids could experiment with different sizes and shapes.
Right.
Highlighting those unique tracks left behind.
It's like encouraging people to become lizard trackers.
Exactly.
Looking for those clues in the landscape.
Yeah.
Love it.
Yeah.
These are fantastic.
Right.
Sounds like Mr. Hendricks really encouraged them to think outside the box.
He did.
Right.
Yeah.
Combining scientific information
Absolutely.
with artistic expression.
It's a great combo.
But let's not forget about the text and the signs.
Right?
Right. What kind of information should be there to make them educational?
Yeah, our sources stress the importance of clear, concise language that's going to spark interest.
Okay.
There are suggested headings like, meet the amazing sand lizards.
Okay.
Followed by bullet points with fun facts.
Okay.
About their habitat, their behavior, or their conservation status.
So something like, did you know sand lizards can change color to blend in?
Perfect.
Or like, these little guys help keep our dunes healthy.
Exactly.
Short, snappy, and memorable.
Right.
Of course, you need a gentle reminder to respect the lizards in their space.
Yeah.
Observe quietly from a distance and help keep these amazing creatures safe.
Yeah.
Something like that.
Love it.
Yeah.
It's all about fostering that sense of wonder and responsibility.
Absolutely.
So as we kind of wrap up this deep dive, what's the key takeaway?
Yeah, this deep dive shows us that even a seemingly simple project, like creating lizard signs, can be a springboard
for exploring the scientific mindset. And it highlights the power of observation, careful planning, and creative thinking.
Absolutely.
Skills that are valuable in all aspects of life.
Yeah.
Not just in scientific research.
Right. It's a reminder that science is all around us.
It is.
We can all participate
in
that process of discovery.
Absolutely.
Whether we're designing signs or conducting experiments.
Yeah.
Or just observing the world with curious eyes.
For sure.
And who knows, maybe this episode will inspire someone
I hope so.
out there
Me too.
to create their own lizard signs.
That'd be awesome.
Or embark on their own scientific adventure.
I love it.
So until next time.
Until next time.
Keep those brains buzzing.
Yeah.
And keep those eyes open to the wonders
Keep observing
of the world around us.
Yeah.